Hi, in today's video I'm going to be talking about ultrasound transducers. Everybody's familiar with the ultrasound little module HCSR04 used for a lot of projects with the Arduino sort of board, mini computer. Basically, most of the people are familiar with them, with this specific sort of transmitter and receiver module, but they don't really know how it actually operates. But nonetheless, we'll try to sort of show it on the scope with little examples, what they actually do and how to actually do it. I'll try to do it in a short as possible sort of manner. Okay, now, basically, what is the ultrasound? Ultrasound is a sound, as it, in sound. And the sound you can basically divide in three different sort of distinct sort of categories. One is from 0 to 20 hertz, which is called infrasound, and then from 20 hertz to 20 kilohertz, which is called hearable sound for us humans. That we can hear and also feel, sort of. And then, of course, from 20 kilohertz up, which as humans cannot hear, but a lot of animals in in an animal kingdom, they can. It's called the ultrasound. So today we're talking about ultrasound transducers, how to produce and how to receive. Now you get basically basic two different types. One is capacitive, and the other one is crystal sort of operated transducer. Of course, this particular one over here is it's a capacitive sort of transducer itself with associated electronics that does the sort of measurements of the voltage received and transmitted and so on, and then sends the signal basically back to Arduino, and with a clever software you can precisely sort of calculate the distance anywhere from 2 centimeters to about 4 meters with the accuracy of about 3 millimeters, which is exceptionally good for such a cheap and small little and simple device. Okay, now I've taken over here two basically, one is called a transmitter, okay, TX. As you can see even on the board, one is a transmitter and the other one is the receiver, although they look the same, but they are slightly different. Nonetheless, I've just taken, loose transducers and then I connected up. And this is sorry, which one is this one? Yeah, this one is transmitting one. Let me just zoom onto it. Okay, and this one over there. Let me just, sorry. And this one over here is the receiving one. So now the transmitting one is connected to a generator, which I'm generating 40 kilohertz if you look at it, okay, into the actual transducer. And of course I'm driving it with a very, very low voltage type of thing, just for a demo purpose that I can display the signal on the scope. Okay, and then the actual receiving one, RX1, okay, just sort of stand up, yeah, RX1 is connected to the actual scope via the probes. Okay, I just stepped up the probes together. So now, if you look at it very carefully, there is no obstacle right now on the front of the actual transducers. And on the scope, you can actually see the signal is very, 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 very small. Okay, it picks my hand type of thing. Okay, so now, this one, yeah, TX1 is sending the actual sound, which we cannot hear, okay, and this one is receiving the sound if there is an object in between. And that can be displayed on the scope, if I put a barrier, you can see the sound is bouncing off this plate. Okay, let me just try. And look at it. Okay, the closer I get, the more, and you can see it's actually running off the scale on the actual scope. And it's a pure sine wave, because that's, okay, I'm just increasing the resolution, because I am using basically the sine wave. I'm generating the sine wave into the transmitting one, and I'm getting a pure sine wave on the scope. In other words, gets picked up over here on the receiving, sends the signal 40 kilohertz, receives the 40 kilohertz, bounced, say, from this boundary. And now look at it here, how the signal will attenuate. The more I keep on moving it away, the less it becomes. I can increase the resolution now on the scope. Okay, you can see, and the more I, and remember, the accuracy is 3 millimeters. So look at it here, tilted a little bit forward, and the angle of reception is increased. It increases the actual signal by quite a bit. Look at it here, straighten a little bit, or a bend it a little bit. It's not really bounce signal reaching 100% the receiver. So basically, this is what these devices actually do on this sort of ultrasound module. One transmits a sound, the other one receives. And as I said, it's a capacitive transducers. So now you could actually see that, yes, definitely, look at it there with the barrier. Look at it there with the barrier again. Okay. Now, the more closer I get it, the more signal sort of obtained, the further I go. Okay. And as I said, it's a very, very, very accurate little sort of device, which gives the accuracy of 3 millimeter, from 2 centimeter distance to up to 4 meter. That actually can be measured. And of course, as I said, if it is now these transducers, if they're mounted on a PC board with associated electronics and connected to Arduino to a display, you can actually display the distance with the accuracy anything up to 4 meter within the 3 millimeter tolerance. So yeah, I hope it was educational, and enjoy this particular video, because it's not magic, it's just a pure science, and yes, it does work. Thank you for watching.